here I'm going to try to graph a piecewise function involved with three pieces this time. The f of x function is going to be equal to -3 on the interval x less than or equal to -2. It's going to be 2x plus 1 on the interval -2 less than x less than or equal to 2, and it's going to be 5 if x is bigger than 2. I'm using the colors black, blue, and green to indicate these so that way you can distinguish them in the graph. So now if I'm working on problems like this, I always like to kind of jump to the endpoints. I find it easier to graph those most of the time. So in particular, if I look over here at all the conditions, I can see that there's something critical happening at -2 and something critical or important happening at 2. So if I stick in the number -2 to the top function, I should get -3. So I'm going to go to -2, -3, and draw a dot. Notice I'm drawing a solid dot because this is less than or equal to. Now for the blue interval, I can see that the critical endpoints are at -2 and at 2. So if I were to replace x with -2 into this rule, notice that 2 times -2 is -4, and -4 plus 1 is -3. So in blue, I'm going to put an open circle also at -2, -3. Again, I'm using open because it's less than, not less than or equal to, and I'm using blue because now I'm following the second rule, even though it's not technically equal to. How about the number 2? So, well, let's see. 2 times 2 is 4, and 4 plus 1 is 5. So I'm going to go to 2, 5. And there I'm going to draw a circle or a dot, but that one's solid because of the less than or equal to part. So those two are from the blue part in the middle. Okay, finally, I'm going to use the green in order to graph what happens when x is bigger than 2. So if x is bigger than 2, I'm going to have 5. It's bigger, not bigger than or equal to, so I'm going to put an open dot at 2 with an x and y with a 5. So that would look like this. So now I'm ready to construct my graph. In black, that -3 value is indicated right here, and all of the values less than or equal to -2 are always -3. So I'm going to draw a line going this way, and that's the straight line representing all outputs that are -3. Between -2 and 2, I have to connect the two blue dots via this straight line, and so that straight line would go like this. Notice it does go through the y-intercept of 1 just like we would expect, and it does have a rise over run or slope of 2. Now finally, the green piece is for all the x values that are bigger than 2, and they're always supposed to be 5. So from here and all the way to the right, I'm going to draw 5. Notice this is certainly the graph of a function, right? This is a function because it passes the vertical line test, but the graph itself consisted of 3 different constituent parts. A straight line or a horizontal line at -3, followed by a line with a y-intercept of 1 and a slope of 2 between -2 and 2, and then finally a horizontal line at 5 extending off to infinity. And this is how you graph a piecewise function.